functions fx is equal to 2x minus 12x plus 13. And since this is your quadratic given, the examiner will tell you to change it to completing the square form. Knowing the fact that completing the square original is ax minus h whole square plus k. But sometimes the examiner will always give you the own expression such that the examiner will want it to open at ax plus b whole square plus c. So if we just open this thing up, now this can be your first part of the question, that change your quadratic to completing the square form. So if we just do it, that is 2x square minus 12x plus 13, and we can open this x plus b whole square. This should be x square plus 2xb plus b square plus c. 2x square minus 12x plus 13. We need to open this to the fullest. That would be ax square plus 2axb and ab square plus c. Now, since we have open completing the square form and we have quadratic form, we know this, that the comparing method can be used to identify or take out the values. Comparing method, which means your x square will be compared to x square, which is 2x square is compared to ax square. X square is cancelled. A is equal to 2. Minus 12x is equal to 2axb. Because of x, it is compared to 2axb. So this would be minus 12x is equal to 2. Substitute the a value that is taken out. This would be 2x and b. X and x is cancelled. Minus 12 upon 4. So that means b value becomes what? Minus 3. Similarly, we have a constant which is 13. And we see that ab square plus c is constant here because it does not carry x square or it does not carry x. So considering 13 is equal to ab square plus c, your a value was taken out as 2, whereas your b value is taken out as 3. And we can write down this thing as what? 2. 3 square minus 3 square is 9. 9 to 2 is 18 plus c. 18 goes on the other side. 13 minus 18. So c value becomes minus 5. So this becomes the value. These are the values of a, b, and c. But the examiner actually told you to write down this thing in the completing the square form, which is a x plus b whole square plus c. A value was 2. Your x will remain same, but b value is minus 3 whole square, and your c is negative 5. Because of all the values, we wrote down the completing the square form. Now, this completing the square form is basically ax square plus bx plus c is identified as ax plus b whole square plus c. And knowing the fact that we had this thing as quadratics and this thing as completing the square form, completing the square, this creates curve, whereas this creates turning point of curve. Now, simply, if I say that we had 2x square minus 12x plus 13, and your values were 2x minus 3 whole square minus 5. Now, since you have this quadratic equation in front of you, that is 2x square minus 12x plus 30, and you have completing square in front of you, that is 2x minus 3 whole square minus 5. The other part the question would want you to do is sketch. Sketch the graph. That means using what? There are three things that you need to use to sketch. Number one, the examiner would want you to write down turning point. The examiner would want you to give the y-intercept. The examiner would want you to give that A should be greater than 0. It would be a U-shaped curve. If A is less than 0, it should be N-shaped curve. At some point, if the examiner asks you the x coordinates, so y is equal to 0. So to take out the x coordinate, y will be 0, and obviously equation will be solved. But looking at the question now, we have 2x minus 3 minus 5. So this is 2 x minus 3 whole square minus 5, and the quadratics was 2x square minus 12x plus 13. There are three things that you need. Your turning point will come from completing the square form only. If this is minus 3, that means your x coordinate sign will change. This will become 3. And the basic reason for that is that the original figure, the original expression of your completing the square form is ax minus h whole square plus k. So if you note that this particular sign is negative here. So if this is negative and this is negative here as well, so that means this negative will be part of the formula. So 3 will become positive. Similarly, your sign of y will remain same, which will be negative 5. So this becomes your turning point of the graph. Your A describes, since it is A greater than 0, it is positive. Your A describes what? A U-shaped curve. This thing describes y-intercept. That means this 13 will become y-intercept, because in the quadratic formula, if we substitute 0 in place of x, that means you are actually finding out what? 13. Because basically if this is written down as 2x square minus 12x plus 13, in the question this fx is described as what? Y. 2x square minus 12x plus 13. And every time when you need to find what y-intercept, your x coordinate is 0. So if we just put down this thing as 0, so this should be what? Y is equal to what? 13. So 13 should be the y-intercept. Now, there are three things that were needed. One thing was 3 minus 5, which is your turning point. Y-intercept, your A greater than 0. If required, the examiner will ask you to find out the x coordinates of the question. So if I said that y is equal to 2x square minus 12x plus 13 can be written down instead of fx as well, because that represents the equation of y. So if I say for what x coordinate y will be 0. So can I substitute y and write down this equation as the given formula? That is 2x square minus 12x plus 13. In this case, what we can do is we can either use middle term breaking, or we can have quadratic formula, considering that you need to have what? Values of x. But normally these three things are important. One is your turning point, the other thing is a greater than 0, less than 0, the third thing is y-intercept. Now, knowing the fact that your y-intercept was 13, your x is 3, whereas your y is minus 5 of the turning point, your x should be 13, and you know that your graph is going like this. Clear enough? Any issues? Now, what we initiated with was quadratic to completing the square form, then completing the square form to turning point, y-intercept, and obviously knowing that it is a U-shaped curve or an N-shaped curve. Now, if the domain of question is x is element of real numbers, that means this is a limitless domain. This also identify all values of x. All values of x. Since it is a limitless domain, it will be considered as what? All values of x. Now, knowing the fact that your graph was like this, making it a little shorter this time, -5, this was 13. And your graph had y-intercept 13. It came down till -3 and 5, and obviously it went back again. So what does x is element of all the real number means? That means any values of x on the right hand side, any values of x on the left hand side. Obviously these middle values are already part of the graph, right? But any value, that means these values of x positively or these values of the x negatively will keep on going. So that means my graph can also be extended upwards. My graph can also be extended upwards. The question can ask me in part 3, when x is element of real number, write down range. Write down range. So if you notice that your range is basically values of x. Sorry, your range is basically values of y. So knowing that range is values of y, your x is element of real number, that means we are talking about domain. So when domain is limitless, so that means your range should also be limitless. But at the point, what does range means? Can I say that my range of y will not go below -5? Because since the graph was coming from the decreasing function, the graph was coming downwards, we turned the graph from -5 towards upward. That means the minimum value will be what? -5. So if I want to write down the range when x is element of the real number, this should be fx. Always range is shown as fx. Normally for what? fx function. For fx function ax square plus bx plus c, or fx is equal to ax plus b whole square plus c. For fx function, your range will be shown as fx. It should be greater than equal to -5. It should be greater than equal to -5. That means all the values will be above -5 for this particular range because of the turning point. So when we talk about fx, and this is known as ax square plus bx plus c. This can be used as ax minus b whole square plus c, x plus b whole square plus c. The question for any of the quadratic or the completing the square form will have the concept of that this quadratic equation does not have inverse. Your quadratic equation does not have inverse, or in other words, I will say it does not show inverse. It does not show inverse. Now, why does it not show inverse? Because quadratic is one-to-many function. Quadratic is one-to-many function. What does it mean by one-to-many function? That we have x-axis and we have y-axis, and I draw a curve. For each value of y, particularly, you will have two values of x. So that means it is what? One-to-many function. And whenever you have one-to-many function, it does not have inverse. So, when do you have inverse? Your inverse will be when we have one-to-one function. So that means when will we have inverse? When we have one-to-one function. And your quadratic does not show inverse, but the completing the square form has a point from where inverse starts or ends. Your completing the square form has a point from where the inverse starts and ends. And that point is basically turning point. That point is your turning point. Now, what does it mean? This clearly identifies that your x and y, if I just draw a curve here, a quotient clearly identifies that this becomes your turning point. From this point, if I see that if this line is removed, that means particularly this is shown x is greater than a. That means if the graph is for x is greater than a, this identifies that we will be looking forward after the turning point. And when I'm looking forward for after the turning point, what we notice is for each value of x, we have only one value of y. Because now this part, x less than a, has been removed. This is not required. The only requirement is x is greater than a. So when we have x is greater than a, only a line is drawn, which is shown as red part. Only this line will be drawn, and this will significantly tell me the value of x and value of y. And what does it represent? It represents one-to-one function. It represents one-to-one function. And always, whenever we have one-to-one function, it will have an inverse. Whenever we have one-to-one function, it will always have an inverse. So considering the fact that we have the same question that says two x minus 3 whole square plus 5 minus 5 it is, and the examiner tells us as part 4, does this have an inverse? When x is element of real number. When x is element of the real number. So this particular question, because the normal fx is your quadratic form, which is 2x squared minus 12x plus 13. So can I directly say no? It does not have inverse because it is not a one-to-one function. So when x is element of the real number, The question says, does it have an inverse? You'll write it down. No, it does not have an inverse because it is not a one-to-one function. Then your other part says, when x is greater than a, when x is greater than equal to a, it has an inverse. Now it tells me that it has an inverse when x is greater than equal to a. When x is greater than equal to a, it has an inverse. Write down value of a. So now you need to understand that your inverse starts from turning point when x is element of the real numbers. Your inverse starts from the turning point when x is element of the real number. So it says x is greater than equal to a. So your graph particularly was 3 and minus 5. This was your turning point. So on the right hand side, it shows x is greater than equal to a. This part shows what x is less than equal to a, which is not required. So the graph will go like this only. That means my graph will have a curve that would show the increasing function. Now continuously noting this, that I have to write down value of what? X. From where the inverse starts. So where does the inverse starts from? Your inverse starts from a, and your a value becomes what? 3. Even if the question would have been when x is less than equal to a, it has an inverse. If the question would have been like this, x is less than equal to a, it has an inverse. And it would have said, write down value of a. Write down value of what? A. So this particularly means the examiner actually wants us to write down the inverse. This is 3, knowing the fact this is minus 5. This is your turning point. This was 13. So the graph will only be drawn particularly for less than till this point. So this point is x less than equal to a. So at this point as well, your a will become what? 3. But the value, the inequality has changed because x is less than equal to 3. That means left hand side from the turning point, because your graph is a U-shaped curve. Whereas for x is greater than equal to a, it will be a right hand side curve because of the turning point required in the question.